Welcome to Understand the Math. In this video, we are going to learn how to solve logarithmic equations. We'll look at two common types of examples. One, where all the terms in the equation are in the same logarithm base, and another, where the equations have a constant term. We'll go through each type of equation step by step so everything is easy to follow and makes sense. We're going to start by looking at examples where we're going to solve logarithmic equations that have all the terms in the equation in the same logarithmic base. If you glance down at the bottom of the page, you can see what one of those equations looks like. Each term in this equation has a log in it. Just to make things easier, I've written down 3 steps that we can follow, and I'll go ahead and go through these really quickly. The first step is that we're going to combine and simplify the logarithms on each side of the equation. To do this, you may have to use these 3 logarithm properties. I have a video on these properties if you need to review that. The second step that we're going to do is solve the equation by applying what we call the one-to-one property. This property just tells us if you have a logarithm with the same base on each side of the equation, then the quantities inside the logarithm are equal to each other. And then our last step is to check to see if we have extraneous solutions. And I'll show you what that looks like when we go through one of our examples. Let's now solve our first example problem. Our first step is to combine the logarithms on each side of the equation. Notice that on the left-hand side, we have 2 logarithms, and we can combine them. They are being added, so that means we can combine them by multiplying x and x minus 1. And then the right-hand side is just going to be log 4x. Let's go ahead and multiply the x and the x minus 1, and we get log of x squared minus x is equal to log of 4x. The second step tells us that we can solve the equation by equating what's inside each logarithm. So let's write down x squared minus x is equal to 4x. We can solve that. Let's pull the 4x to the left, and we have x squared minus 5x is equal to 0. We want to factor out an x, and we're left with x minus 5 is equal to 0. And then we set both of those quantities equal to 0, and we get x is equal to 0, and x is equal to 5. Our third step is to look at these 2 solutions that we just found and make sure that they are not what we call extraneous solutions. Extraneous solutions are just solutions where one or more of the logarithms in the original equation would be negative. Remember, when you're working with log x, it's only defined for x is greater than 0. Let's look at our first solution. X is equal to 0. If we plug 0 back up into our original equation up here, you can see that we have a log of 0 and we have a log of negative 1, and those are undefined, so x is equal to 0 is not going to be a solution. It's what we call an extraneous solution. Now let's check x is equal to 5. If we substitute 5 back up into our equation, all the logs are positive, so x is equal to 5 is a solution. So let's just go ahead and write down for step 3 that we have the solution x is equal to 5. Let's look at another example. In our second example, we're going to be working with natural logs, and we're going to solve the equation 2 ln x is equal to ln 2 plus ln of 3x minus 4. We'll use our 3 steps that we just talked about. Our first step tells us that we are to combine and simplify the logarithms on each side of the equation. Notice on the left-hand side that we have a 2 multiplying our log. In order to equate our logs, we cannot have any constants in front of them. So we need to simplify the left-hand side, and we're going to use the power rule and write it as ln x squared. we just bring the 2 up into the exponent. And then on the right-hand side, we have 2 logs added, so we can combine them into 1 log and multiply 2 times 3x minus 4. Let's go ahead and let's simplify this. The left-hand side's going to stay the same, ln x squared. And then the right-hand side, we have ln 6x minus 8. Our second step tells us that we can use the one-to-one property and just equate the x squared with the 6x minus 8. So let's write down x squared is equal to 6x minus 8. This is a quadratic equation and we can solve it. Let's pull everything to the left-hand side and we have x squared minus 6x plus 8 is equal to 0. We can factor this. Let's go ahead and set it up. We have an x here and an x here. We need to find 2 numbers that multiply to get 8 and add to get minus 6. And those 2 numbers are going to be a minus 4 and a minus 2. So let's write down x minus 2 and x minus 4. This then gives us the solution x is equal to 2 and x is equal to 4. Our third step tells us that we are to check for extraneous solutions. So if we look back up at our original equation and we substitute in x is equal to 2, all of the logs are positive, so that solution is good. And then if we do the same thing for x is equal to 4, also all of the logs are positive, so that solution is good. So for step 3, we can just write down that we have the solutions x is equal to 2 and x is equal to 4. Let's now look at some examples where we will be solving logarithmic equations that have a constant term in them. Let's look down at the bottom of the page and look at our first example, and you can see that this equation has a log on the left-hand side and we have a constant on the right-hand side. So this is a logarithmic equation with a constant term. I have written down 3 steps that we can follow, and we're going to go through these one by one as we walk through our example. Our first step tells us that we are to combine all the logarithms on one side of the equation. For the example that we're doing, this is already done, so let's just write done. In our next example, we'll actually have to do that step. Let's now look at our second step. We are to rewrite the logarithmic equation in exponential form and then solve the equation. I've written down in this green box how we can take a logarithmic equation and write it in exponential form. Let's go ahead and let's do that. You just take the base, which is 2, I'll highlight that in pink, and then raise it to the constant on the right, which is 4, and it's equal to then whatever is inside the logarithm. Now we can go ahead and solve this. 2 to the 4 is just 16. And then on the right-hand side, we have 3x minus 2. Let's bring the negative 2 to the left. And that gives us 18 is equal to 3x. So we have x is equal to 6. Now we're almost done, but we have a third step. And that third step is to check to see if we have extraneous solutions. So what we're going to do is we're going to take our solution x is equal to 6, plug it back up into our original equation, and we see that inside the log, we have 3x minus 2 is equal to 16, and that's greater than 0, so we're all good. We can then just write down our solution, x is equal to 6. In our second example, we'll actually get an extraneous solution. Let's go ahead and let's do that example now. In our second example, we're going to solve the equation log of x plus log of x minus 3 is equal to 1. We're going to follow the 3 steps that we just talked about. Our first step is to simplify and combine the logarithms on one side of the equation. We have 2 logarithms that are being added, so we can combine these and write this as log of x times x minus 3 is equal to 1. let's go ahead and multiply out what's inside the log. This gives us log of x squared minus 3x is equal to 1. Our second step is to write this logarithmic equation in exponential form. To do this, we have to remember that when we just have a logarithm log, it has a base of 10. To write this in exponential form then, we're going to take our base 10, raise it to the number on the right-hand side, which is 1, and set it equal to what's inside our logarithm. Now we can go ahead and solve this quadratic. Our quadratic is 0 is equal to x squared minus 3x minus 10. We can then factor this. We have 0 is equal to x, and let's put an x here. We now need to find two numbers that multiply to be minus 10 and add to get minus 3. Let's think. That will be the numbers minus 5 and 2. So let's say plus 2 minus 5, and that gives us the solutions x is equal to minus 2 and x is equal to 5. Now our last step is to take these solutions, put them back up into our original equation and see if we have any negative logs. And indeed we do. If we take x is equal to negative 2, put it right back up into here, we have log of negative 2, which is undefined. So this solution is not valid. But if we take x is equal to 5 and put it back up into here and here, both of those logs are positive, so that solution is okay. So for step 3, let's just write down that x is equal to 5. And we know that we have checked to make sure that that is not an extraneous solution. And that's it. Here are a few things to keep in mind. When you solve logarithmic equations, you want to start by identifying what type of equation you're working with. One where all the terms in the equation are in the same logarithm, or one where the equation has a constant term. And then just follow the steps that we went over. With some practice, you'll get really good at solving these types of equations.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.